Hello and welcome to session 7 of the bending members. In this session, we're solving an example on lat loading unsupported members. In this example, we're going to design a simply supported beam which can carry 35 kilonewton per meter as a UDL, and be careful that the yielding moment of the steel is 300 megapascal. First, we have to calculate the factored moment. Factored moment is equal to omega F L squared over 8, which will be 35 times 7.3 squared over 8, which will be 233 kilonewton times meter. First, we have to pick an initial member. Okay, we have resistant moment. Our resistant moment of the member should be bigger or equal to 233 kilonewton times meter, and our unblazed length is equal to 7.3 meters. So we will try W section 310 to 74. This W section, if you look at the table, for LU equal to 7,000 millimeters, you will have the resisting moment 240, and for LU equal to 8,000, you will have 204. If you do linear interpretation here, MR for LU equal to 7.3 meters will be 229 kilonewton times meter. We know that this is 1.7% lower than what we want to be. It is 1.7% lower than our factored moment, but we're going to accept that because it's close. You can find section properties on page 5. Properties is in chapter 6. Page 6, 48 of the handbook. Now we have to determine the class of the section. First, we'll determine the class of the flange. For the flange, P over T is equal to 205 over 2 over 16.3, which is equal to 6.3. And we know that B over T equal to X over square root of Fy. And if we want to calculate X will be 109.11, and B over T, which is 109.11 over square root of Fy, is lower than 145 over square root of Fy. Therefore, flange is class 1. Now we have to do the same for web. H over W is equal to 310 minus 2 times 16.3 over 9.4 is equal to 29.5. Therefore, H over W is equal to X over square root of Fy, and we can understand that X is equal to 510.9. And as you can see in the table, H over W is lower than H over W, which is 510.9 over square root of Fy. It is lower than 1100 over square root of Fy. Therefore, web is class 1. So web is class 1, flange is class 1, section will be class 1. Next, we want to calculate the resistant moment. First, we will calculate the plastic moment. Plastic moment will be Z Fy, which will be 1190 times 10 to the power of 3 times 300 or 10 to the power of 6. That's for unit. 294.4 kilonewton times meter. Now we have to calculate mu. You remember that we have to find MP and mu to see if MP is bigger than 2/3 of the mu or MP is lower than 2. Mu is bigger than 2/3 of MP or mu is lower than 2/3 of MP. Okay, so mu. Mu is equal to omega 2 times pi over L square root of E IY G J plus P E over L squared times I Y CW. As we know that this is simply supported, so omega 2 will be 1, and we know that mu will be 256.8 kilonewton times meter. Now we calculated mu. We have to check that this mu against the 2/3 of MP. 2/3 of MP is equal to 239.2 kilonewton times meter, which is, so mu is bigger than this number. Therefore, our resistance moment is calculating like by this formula. 1.15 times 5 times MP times 1 minus 0.28 MP over mu, and it should be lower than 5 times MP. So the left hand side will be 225.7 kilonewton times meter. Right hand side will be 321.3 kilonewton times meter. And as you can see, this one is bigger. So the resisting moment is equal to 225.7. It is slightly lower than our factored moment, but because the only difference is 3%, it will accept this number. Thank you for listening to this session of my lecture. If you have any question, you can either comment or email me.